Next, we go to the Minitab. We will introduce the part 5 MSA in Minitab. How to do that MSA. In MSA, we will introduce gauge launcher, gauge are not study closed, and the gauge are not study nested. And first, we can see the path of the Minitab. You can from the status quality tool, and you can see the gauge launcher, gauge linearity, study, gauge INR, gauge closed, gauge INR nested. You know, the difference between the coast and the nested is mean the coasted can each part can measure several times by different operators, but in nested is destroyed. So one part they measure one times, they will broken. They cannot measure for second times. So this such measurement is called nested. Okay. So once again, we introduce, the tolerance in gauge INR can be separated into the, the process and the MSA, and for measurement arrows, it can be divided into the EV and the AV. So if you use the S bar R method, you can just divide the measurement arrow into EV and AV. If you use the ANOVA, it also can divide the arrow into the interaction of operator and parts by operator. Okay. That's the whole system, the variation source of variations. You can see the whole the MSA belong to EV, belong to EV, AV. Okay, first we will introduce gauge launcher. Also, we use the gauge GR1, and we follow this pace. We stack variable, then we can see the reload, something like that. Okay, so if you see reload like that, let's in these figures, let's pass 1, pass 2, pass 3, and the 3 operator to measure. So in this round chart, you can know ND, the blue one ND, and the red one is Ben. The blue, the green one is Casey. So you can see and Ben here. Part 1, part 2, part 3, it's not reliable. Okay, so let me do for you for this case. Okay, that's the case of gauge launcher. So we can see this is operator ND, Ben, and KC, and the major parts 1 twice, parts 2 twice, and the parts 3 twice. That is the measurements. So right now we're going to do gauge launcher. Okay, quad tools, gauge study. Okay, here launcher. Okay, here launcher. Okay, so price numbers, operators, measurement C3. So maybe we just get information. If you give them, you can just give it here. If not, just keep empty before. Okay, the option is the same. You can name the video title here. Okay, you click OK. So, you can see, the results just like the slide. Okay, okay, let's go back to our PPT. Okay, okay. Next, we introduce how to do gauge INR study. Gauge INR closed. Okay, the same case. Uh, the same case. We can find the test and check here. The method of analysis. So if we use the ANOVA, we can have the more detailed information. If you use the S bar, we just go back to just here, okay? Just here. If you want to use S bar method, you can divide the valuation into the EV and AV, okay? If you use ANOVA, you can have the more detailed information, okay? Okay, let's go back here, okay? Okay, so just follow 1, 2, 3, 4, okay? We click OK, so we can, so here in options, please, right now we have to calculate the percentage of the tolerance. So in this case, tolerance is 1. Please type 1. So okay. So the output of Windows, we can check the percent of the contribution. Okay. Okay. We mean that's the tolerance, the gauge INR. We less than 10%. That's grade A. Good. Okay, if the between 10% to 30% is grade B, that's acceptable. If larger than 30%, that's mean grade C, cannot be trusted. Okay. Okay. Also, we also can find the NDC. If the NDC is larger than, at least the NDC should be at least 5. Okay. So this is the reload. So from this reload, we can find let's variation contribute from the MSA from the major systems. So it is larger than 30%. 13%. So this major system cannot be acceptable. Okay. So also we here is also larger than 13% unacceptable. The NDC is equal to 1. So we hope the NDC should be at least 5. So we can let the S bar R. So the R bar is out of the control. That means just we go back. We go back here. Okay, if the R bar is out of control, it means inconsistent between the operators. Okay, so so we can make for this. Okay, so we will make a quick conclusion of this analyze. So the firstly, the gauge, the contribution of the measurement systems is about 37, which is larger than 30, so it's unacceptable. and you know the gauge tolerance. Percent of tolerance also greater than 30%. So it also indicates the grade C unacceptable, and the NDC is 1. You know, we want to lay at least larger than 5. Okay, so in this analysis, we can check the measurement system is not reliable. Okay, this is the assignment of our assignment. The first one, we have to use the file sketch.aih.ntw. So, you know, this case is acceptable, okay? But you have to, if you do this assignment, you have to put the tolerance is 8, okay? This is the case 2 of our assignment, okay? So this system, in this system is unacceptable. So please follow our construction to do your assignment. Okay, let's demonstrate how to do MSA gauge R&R analysis for the GR1 case. Okay, so we follow this test, the stats quality tools here. Gauge study, we type closed, you know, closed. And here, part number, we type C2. In operator, we choose C1, and the measurement data is in C3. Okay, so here we can, you know, the ANOVA can provide more detailed information. So in, you know, in the option, we should determine the tolerance here. Tolerance, yeah, just here. We put 1. Okay. Okay, we click OK. Okay, that's sure. So we also find the SR, S char, R char can have the out of control. That means the inconsistent between operators. So we go back to so here you can find the errors caused by the major system is 37. 37 is larger than 30%, is unacceptable. Okay, so here is tolerance. Tolerance percent of tolerance also larger than 30% is unacceptable, and the NDC here is 1. So if its a major system is reliable, we have to ask the NDC should be at least 5. Okay, so that's the demonstration of gauge GR1.